cities and also smart manufacturing. I will highlight what are the current challenges in this area and what's the impact on building intelligent and autonomous systems, in particular vision systems. And then I will present how to do that, how to address that through the D7R4 process. And I'm going to touch on some techniques, some examples, and on the ethical side as well. And I will bring some conclusions after that. So just to say, this talk is covering at least 10 years of my research. So smart cities are like one of the United Nations goals. So at least more than 40% are already living in cities of people and through the world. This trend is just growing. So one of the main goals is to improve cities, to make them more smart, to help people to live in a good way. So what are some of the challenges for us as engineers? So to have accurate algorithms. So if data have to be real time, or like to say where to go, like for the cars, for the trucks, etc., they want to have real time and accurate data. So that's one of the challenge, obviously. The other one is, as new challenges comes, like the energy efficient algorithms. So if they need really specific hardwares, etc., time consuming but energy consuming, or these kind of things, that's not the best solution. So people want a cost efficient, energy efficient algorithms and systems. The other part from the citizen are like they want explainable AI algorithms. So they want to understand the behavior of any autonomous whatever vehicle around them, or any kind of robot, even chatbots, etc. So they want that these systems are explainable, and actually they want transparent systems. So transparent is also like for regulators. So if there's like an accident with a car or autonomous vehicle, etc., so that should be transparent what happened for regulator, for investigators, etc., as well. So in the white case. So the main concept now is like to build not only systems which are efficient. This was like previously already, like in the over decades, but with the new constraints on energy, explainability, and trustworthiness. That's one of the main aspects. Same for smart manufacturing. Well, that's another goal. That's the goal number 9 of the United Nations. With this Industry 4.0 revolution, people want again accurate algorithms to run the factories, but also time efficient, obviously, but also like cost efficient. If you have to invest in a factory, or like make changes from like the factory they have to the new Industry 4.0 aspect, they want it's not too expensive. But there are other things, again, like explainability, because people will work together with robots or any kind of intelligent device. So they want to understand what's happening. Should be not no harm for people inside. Should be also not, like no harm for the existing equipment by this new autonomous system going through, etc., the factory. So that's the important thing. And for people to communicate with robots, and also like if it's like different type of robots, machines, autonomous system, etc., they should be interoperable, so they can all communicate well in a meaningful way. So all that also brings the trustworthiness aspect. So to address that from the engineer point of view, from the point of view of designing, developing such system which meet the requirements of industry or the society, like Society 5.0, well, we need to know how to approach that. Well, there's a lot of questions, like which algorithms we have to choose, which tool we have to use to develop such systems, what data to use to train our system, some ethical consideration, they should do no harm, etc., to people, etc., so bring well-being. So again, which techniques, how to do that, how to test, that's not easy. I'm going to touch on that, which metrics to use, well, and there's like standards ongoing, which standard to use to get certification of this intelligence system. So as it's like a lot of keywords, perhaps if you can have much more in your mind, but the best way is to follow a process. So like that, you know which step you follow, so you don't miss any important or crucial point of this development of systems. So for that, I've developed a D7R4 process. So again, this was published in 2019. So this was like 7 steps, the blue steps, like which can be iterated from the beginning to the end, and also some reviews of the green steps. So if I'm going to detail, the first step is to discover, so to understand the context of the study. Dig project is to understand the domain and look at what are the existing tools or standards, etc. So this is our important steps, which kind of do not exist. If somebody has to develop just a website, they already know what the website is, which tool to use, PHP or whatever, etc. Here in AI systems, the path is not like so much yet established. So these steps should be incorporated at the beginning of a study. So then there's like the usual step of describing the requirements, whatever for the system, softwares of the users, and then the design. But it's not only including the software itself or the system itself, but also like what databases, which data to use, how to, what are requirements for the, and what's going to be the design of the algorithms as well, to have the intelligent and autonomous part in it. So the development, then how to implement and test, demonstrate, and integrate, and finally deploy and get approval, like through certification. So that's the steps. The reviews could be like quality review around like the new keywords, so not only quality softwares, but also like, is it compliant to standards? Is it trustworthy? This kind of aspect. AX, this is beyond user experience. This is agent experience, because it's not only for people, but we can integrate that in robots, any autonomous system. So, and also all the aspects of human-robot interaction. So it should be a good experience for whatever a human agent or like an artificial agent. And this interoperability, how to address that the communication is done smoothly and efficiently. Other reviews could be the ethical one, if you have to pass GDPR in Europe, or over standards, and also like what's happening to the data sets, are they like unbiased, things like that, and security. So this is like what could be cybersecurity, but also it could be safety of the people, of equipment, etc. So how to do, so I'm going to illustrate the steps now through projects I've developed with my team. So first, the first stage, discover stage, is the study of the project context. So if I have like the example of the context of a rescue mission, so in a kind of dangerous, maybe dangerous environment, so like to assess the situation, actually to discover like people inside, if they need help, if they need rescue, etc. So the new trends are to send a robot first to assess the situation before sending the people, the rescuer, to the scene. So for that, in this context, we've developed a robot, which is on the right. This is the robot on in our lab. So my student developed it under my supervision. So that was the general context. So now what we need to know. So first, obviously, what intelligent vision systems are. So for people, it's just like anything which can think and which can see. So through cameras, because that's like artificial systems, they see through cameras, this kind of sensors. Well, intelligent, that means there will be some lines of code. So algorithms are coded in programming language, and actually this will turn out in doing the full software. So it's not like an algorithm in isolation, but actually it should be embedded in the software, which is embedded in a system, and also connected to hardwares, like if we need cameras, etc. Obviously, for vision systems. So this is a formal definition. Again, bring that in another paper in 2019. So to say that intelligent vision systems are a set of interconnected hardware and software components which take digital images. So they could acquire them in real time, if it's like camera processing that, if it's like robot moving. It could be also like if it's like just agents, like online agent, etc. They're just like they are processing already still images or acquiring like videos from any data set which is online. So it depends. So it could be any input data which is in form of images, and then they process that with a range of techniques. So it could be just low-level techniques with some image processing. It was called before, or computer vision, or like adding more and more machine learning, getting to more and more intelligence in the system. So this, how many intelligence should be in the system, is something also that will depend of your project. And at the end, what the people want is like from an intelligent visual system is information and even better knowledge. So if we add more knowledge representation, we can really get to an automatic understanding of the gathered visual data. So now if we look at the project in more detail, if we know the general context, then we have to touch on the techniques. I've said it could be just image or video processing, computer vision, more pattern recognition, and then AI. So it's underpinned by over also computer science paradigms, on over algorithms helping to process data. So it's, and also, like I've said, we need at the end to develop a full software, usually to have it like a product, a commercial product embedded in cities, smart cities, or in manufacturing. So the other principle of software engineering are also applying here. So it's why the problem is quite complex to develop an intelligent vision system. So there's like other challenges more specific to vision. So for example, if we look at this picture, so if the question is like, what is this object? So perhaps you have already in mind that the answer is just violin. So this part of visual object recognition, your eyes are and the cells are like recognizing shapes, colors, etc. Your brain's processing, and you know the keyword, the label, if you want, attached to that. But that's not so easy for autonomous systems, even if they are intelligent. So if we do any training, any learning on the first picture, or like similar first pictures, then we get some difficulties to recognize this kind of image. So it's still a violin, somebody playing the violin, but what happens, like blurred resolution is not as good. There's some occlusion because of a bow and other things like fingers going on the violin, etc. And the rotation, there's some rotation already. So it's first type of difficulties which could happen. And otherwise could be like below. So what's happening, like the object on the left side on the top is still a violin, but even more occlusion, and there's like even more rotation compared to the first picture, and the color has changed. The color is really different from the previous ones, and that's the intra-class dissimilarities. So within one class of object, if even if we do training, it could be differences. And also, like, it'd be other things. So actually the color is similar of the violin to the guitar, which is just to the right of the picture, right? Like much closer than to the previous picture of the violin. So these are like interclass similarities, which even make the problem more difficult. So it's why it's still like an ongoing research on how to address these things well. For autonomous systems which are like moving and people want to communicate with them, for example, I still remember like a robot going to assess the situation, and the commander speaking to that, they could have a different view. It was like a one city camera, and the robot is sharing other images, so there's a need sometimes to coordinate the views, for example with matching points of like matching interesting points or local descriptors, etc., to coordinate the scene. And then if we go, like we say to the robot, go to the right of the sofa, he knows exactly what we mean by that. So another approach, for example, taken with drones, that the view of the commander is the same for the view of the drone. So it's like the commander see through the eyes of a robot, if you want. So that's robot-centric view. So it's safe on this coordination of landmarks, but well, that could be over issues again described in over of my papers. So you need to know in which context you are. Are you robot-centric view? Are you like, do you need any coordination? Which data you need to train to have a good results, etc. So these are the things you need to dig in the second stage to know to which level and which angles you need to choose in the next steps. So you need to put like in the third steps, like clearly your requirements down on a paper. For that, also you need to define which level of autonomy your system is expected to have. So it could be from not autonomous, like with a lot of helps of people still, or semi-autonomous. So sometimes doing some tasks autonomously, and some are like with the help of the people, and perhaps fully autonomous. So a lot of the time now, we think, we assume that there's like a person in the loop at one point. So like fully autonomous are like not the most common. So even if it's like autonomous systems are like a buzzword, usually systems are like semi-autonomous at this moment. So that's important to keep in mind. So autonomous systems can be programmed to autonomously take actions or make choices based on input from visual sensors. It could follow different architectures. So like the old architecture was just like have like there was like sensing, going for a planning, which was pre-programmed, and then doing the actions and back sensing what was the results. Well, people wanted more like quick reaction to this kind of system, because this was like going for full planning. Sometimes it was a bit slow in reaction. So they bring in robotics the reactive paradigm. So it was sense, act. But then some were thinking like it's more like sometimes random actions, or like not suited action, not enough intelligent in it, in this kind of paradigm. So the current paradigm is of a hybrid paradigm. So, well, if it's like an easy action, or like it could be like a direct action produced without any planning. Otherwise, it needs some more planning and programming to react to what was sensed. But this again, we can go further if you have like this human-robot interactions, and I've said this assumed in many standards which are developed now that there's a human in the loop somewhere. I've proposed a few years ago another paradigm. So we replace the planning in the hybrid mode by interaction. So it could be a pre-programmed planner, but also it could be, the I could stand for human interacted directly into the system. So it's like a fourth level, and the design of human envelope within systems. So this was tested on our robot in the lab. So that's important, like how you see autonomous systems, and to integrate, which is required, the human envelope. So still somewhere a way to take control. So it's what's happening in the airplane. So they could be autonomously fly at one point, but the pilot at any point can retake control. That's a bit like the philosophy behind that. And also transparency. So this is asked by the users, by the society, by the regulators. So if you want to really certify and bring your product to market, you should bring evidence that your system is intelligent and autonomous system is transparent. So what's transparency? That's the property which makes possible to discover how and why the system made a particular decision and acted the way it did, taking into account its environment. So the thing is, like, there's also, again, different levels of transparency. So it's like from the standards 7001, which are printed in 2021, I was part of the working group. There's like 5 levels of transparency for each system, and also like it depends of the requirement to assess if it's like which level of transparency are changing, depends if it's like from the point of view of the user or the regulator or the designer, etc. So that's one point. Now the machine learning transparency. So from 2019 in the study, the author has analyzed a lot of these techniques and papers. I came to the conclusion that at the moment, the most transparent are still the logic rules. There's like a trend now to embed more logic, because still like the neural network deep learning are not so much transparent still at the moment. So there's a trend now to try to have like logic rules combined with the neural networks to get benefits of both. But still, this table is still something to keep in mind when designing or selecting the algorithms for your system. So it depends to which level of transparency you need to acquire to get the certification. So now, not only transparency is important, there's also like IEEE or the international level. There's also like the guidelines by the United Nations. There's also like national guidelines, which are also part of this game of developing standards for system to be certified. So there's like a lot of keywords. Transparency is one of the important one. There's some more specific now in development for the explainability. Half of these efforts are still ongoing. So the documents are not yet ready. So the standardization effort usually takes like 3 years or could be up to 5. So some of them have appeared. I've said like IEEE 7001 for transparency I was part of. In some other actions I'm part of, they are ongoing. So like the verification, the IEEE 2817 standard is an ongoing effort. So there's like things that the designers, the engineers need to know that things are going to come. So at one point, the product will need to comply to the new certification. Some are already available. So that's a very important message. So now when you start to design, you need to know these kind of things. So which standard you need to comply? Is it like covering safety or transparency, or what's your regulator needs to from you as a designer? So then I move with my example. So once you have the right level of the and paradigm, you can go to the low level design. So there's like a mapping of high level, how to have the architecture with the sensor, how to move like the wheels, etc., how to connect with the sensors, not only the webcam, other sensors like ultrasonic sensor, for example, etc. So this is like going through the general like patterns, like paradigms to the low level design. So for classes on the coding side, on the software aspect side, to use kind of patterns for your class diagrams, which are labeled as transparent. So we've developed this one. This was with the effort 7007. So this one is published. So how to embed also like classes and behaviors which are ethical and control that. So your robot is not just doing any action, but just like the ones which are allowed, like the ethical actions only. So that's important. Also, like the unbiased data, so the 7003 standards, this is an ongoing effort. It's not yet released, but it's important to know how you train before you test already the training. So if you think banana, so that's like the picture you may have in mind, but you may know that they could have over colors, slightly over shapes, but especially over colors. So if you train your system in recognizing bananas just based on the yellow color, it may miss the over occurrence and the over appearance of a banana. So that's just a simple example, but it's quite clear that you may just bias your system, but choosing not the adequate training data set. So that's really important how you take your data before even testing and other steps. So at this point, you can also do the reviews to help you. So just to stop the blue steps and start to do any of the green reviews here. So for example, if you try to design and build a system which is explainable by design. So if you take the right steps earlier, that's the message rather than just at the end hoping is going to be trustworthy. If you try to embed um, the right algorithms, and if you the right techniques, and if you take care in building your data set itself, etc., or choosing the right one, this kind of maximize your chances of being trustworthy or transparent or passing then the certification. So earlier, spotting all these the challenges earlier is better than just to do a big test at the end. That's the key also message of this D7R4 process, to take at the right time the right steps here. So that's an example on embedding recursive trees and combining this AI approach with vision, with like active contours. So this was in context of smart cities and detecting cars in the city. So if like well parked or like for other aspects, and it was recognizing the car. If it's like from a drone, it could be like the car could be occluded or not entirely visible in the scene for any reason. So this method was robust, not just the detection of the shape of a car, but of the parts of a car. So as this car was represented not only by the general shape, but also like by its parts, it was robust for the detection of the occluded objects as well. So that was the visual aspect which was bringing robustness to the system. The recursive decision trees are like one of the most transparent techniques. So it was like bringing already like an XA by design aspect. So this explanation how the snakes are working, just to show that it was just through minimization of this equation, so it's explainable. This was the framework, not to only rely on shapes, as it's like the initial game of active contours. Contours means like the shapes, but also like bringing colors or other type of visual features in this mathematical framework. And then that was like the full algorithms, again using logics, etc. So we can really verify it and could be well embedded for autonomous systems. So again, maximize changing before and taking the right techniques is a good practice to develop trustworthy, intelligent, and autonomous systems. Then obviously is the development stage, and then the testing. So proper testing needs metrics. It could be different ones for vision systems. There's not just one for segmentation, for example, to see if it's like well segmented picture. There's no one. There could be many. That's a challenge also, just to use to know which one to use. For the aspect of, for example, recognition of objects, etc., this is better because like it's there are like these metrics which are the most used, like the precision detection rate, false detection rate, and accuracy based on the true positive and the false positive, true negative, etc. Right. So this is like this performance for a high level intelligent system are like well established. That's the good news. So for example, if we have assessed with these metrics our previously shown system, we get 95.6% of accuracy. So this was quite accurate. And the first methods, like to 65 or 69%, were the ones using deep learning. So actually reusing techniques with more logic actually was beneficial, not only to transparency, but also to accuracy. Well, we find in this study, but because the pictures were not at so good resolutions, and also we didn't provide too much training sets. So that's the point. It's really like deep learning insensitive to the number of samples to the training. So if you have situation, for example, in industry, you don't have so many samples to train, perhaps it's still good to use or to combine several techniques, machine learning techniques. That's the new approach taken. So further testing, well, I've said not only we have to test, to develop and test the algorithm, but the software within, like the algorithm is within a software, so we need to apply further metrics. And also, like, even the same test but with different metrics will show you different differences. So if we look at the first matrix, which is about segmentation, well, we see that the picture with the yellow are like a bit well, not so well segmented if we look at the second matrix. Because with the first one, we think, okay, both methods are kind of similar. But if we just change the metrics, not the method, not the algorithm, but just the metrics, well, we see the difference is much visible. So that was the other aspect of the metrics. But also we need to look at the time. We say you need time efficient to match the real world applications, real time. So for example, still the red are better performing because they are not so much dependent on the resolution of the pictures, while the overall method was really slower when the image is getting bigger and bigger. So that's other aspects in vision to take into account: the resolution, how it impacts deep learning, how it impacts your algorithms, how it impacts the time of the computational time, etc. So to embed it in a real-time system to make it work. So we have much more written in our book. So this book appeared this year. So if you're interested in how to test intelligent systems, so there's much more to say. I'm a bit constrained by time. So I will move forward to the checking the trustworthiness of the system. So now when you develop, you can check it. You don't need necessarily to check it at the end. Well, that's good for certification, but you need to check at different point in time in your development. I'm going to explain that now. So first, a new paper we established that trustworthiness that means that your system is both dependable and transparent. So dependable comes from the software engineering. So it was defined as maintainable, reliable, so good performance if you want, could be maintained and both safe and secure. But then comes like the transparency aspect, as already mentioned earlier in this talk. So which level of transparency is going to meet your system? So it's as expected by users or regulators. So it could be also aspect, is it trustworthy over time? So this was a big worry that if they learn something and they are released, they could be like certified properly. But what's happened after like being 1 year deployed in the environment? Because if they are like still learning, like using deep learning and still learning new things, perhaps their behavior may change in a way which is not the good one. So that to check if your system is trustworthy over time, that's also new challenge and important aspect to check. So here defined that like you need to recheck the metrics. So if you have assessed your system is dependable at one point of time, that means like the different attributes have met or the right values or greater values than expected in terms of quantifying the different software attributes. So if the attributes are not lower over time, that means that's fine. But if they like decrease, that means there's like a less trustworthy over time. So that means something is happening not well. So it could be stopped and considered as not trustworthy anymore. So this is important to also embed the notion of time in your product and development. So here's like explain how it works for vision systems, for example, for the recognition of object system. So if you establish and apply these formulas at the step of just describe at the requirement steps, that means you constitute kind of ground truth or like your requirements. What are the values you want to meet with your system? And then when you develop, you already kind of can assess, are you on the right track? Are you developing the right system to the level of trustworthiness which was expected by whatever the client, the regulator, or whoever. And then you can check that later. Obviously, in deployment, if you make tests in the real world, in the real environment, you deploy it, and then I've said later you can see it's deployed. But what's happened, for example, half a year later or 1 year later, still like is your system still meeting the and performing as expected? And this you can quantify. So that was like the matter I developed here. Well, the development, I've said all these stages could be iterative, so you can go just in one iteration. Again, depends on the time of your project. But if it's like a project which is taking, imagine, 2 or 3 years, then you can go back and iterate to improve. So, for example, if I take the face detection, well, if you have just develop on easy examples like kind of close to ID faces, that's easy to detect. But what's happening if you deploy in the wide? So it could be like if it's some challenges with lighting. So it could be backlighting or other aspects. So then it becomes much more difficult. Again, it depends if you have trained in kind of lab conditions, and if you develop to real world, that could be a big change, and then you need to adjust that. So again, it's like over papers how to address that, and also like here, also like to be sure, for example, for face recognition, to have the right balance of gender and people background, etc. Not only to train one type of data, and also like the rotation of the face, for example, that's another thing. If people in real life are just not always kind of straight, but just like they move the hands, or they could even like laugh, etc. These all change the recognition. So this kind of considerations could be taken earlier, or like perhaps you can have several loops to refine to improve the performance. If they have been after what first review not as expected, you can improve. So you can go further and further in these systems, and also it depends how much intelligence do you need to bring. It's just like recognition action planning. Do you need to interact, or like your robot is tending to be fully autonomous, so wanting even to communicate. So for example, it could perceive your face, not only recognize it, but also see if you are like happy or bored or sad or thirsty, etc., and then take the action. So you can go further in that, for example, the emotion recognition, to adjust the behavior of a robot, so to have full interactions. And think on this interaction and communication aspect, you can add more interoperability if you want to add more like natural language aspects in the communications. Of a good approach or method is to use ontologies, so which are a set of vocabulary, but not only vocabulary, so relations in between the objects, and there's like the formalization. So there's maths as well. You can perform automated reasoning still with logic. So some of this work are already like part of standards. So this was like part of 2015, and then it was reviewed in 2021. The standards, like how to communicate with robots and what are parts of the robots. This is more work added to that about the vision aspects, like how to describe objects and to map them in a granular way. So not only the object itself, but then the scene with the different objects, etc. Also spatial relation. If I've said rescue mission, you want to communicate, you say, okay, go to the right, come back, move further, this kind of things to your robot, because you just assess in real time the situation. So you talk to the robot in natural language. So these are different concepts I've formalized here in maths to be embedded within the robot and the intelligent agents, actually. So this was like base for spatial relation. I brought a model a few years ago, which was mapped on the face of a clock face. So like dividing the space into 12 quadrants. So like that, if you know more or less where's like 1 o'clock, you have an idea where's 1 o'clock or 3 o'clock, etc. So you can say just to the robot, go to 1 o'clock. So it's much more precise than just saying to the right, because to the right, it could be, especially if it's like crowded scene, etc., to the right could be difficult for the robot to interpret. If we say to 2 o'clock, is narrowing the possibilities and the angle as well. So this is much easier and has still a meaningful it's meaningful for the human. So we know where's 2 o'clock. So it's not, we are not talking with GPS coordinate or things like that to the robot. We can just talk like with natural language. So then we can go and develop that to have like more concept like above, below, etc. by combining on these relations. So the other steps of the next step is to integrate your system, to put all of these things together, and we can embed the temporal aspects as well on detecting things like is it in a scene, what's in the view, etc. And we can modelize all that with logic, so it's transparent. So we can also modelize any trajectory if things have moved or not, and also like ask questions. If it's modeled like that in an ontology, we can ask questions to the robot, and this is translate from maths and going back with keywords. So that's all for the interval part. It could be also used for other parts like observing passageway, for example. It was just 4 cameras. That's another project a bit here, but just to illustrate that we can go forward and forward with adding intelligence. So the passageway was close to a subway, and it was just for security aspect, and it was observing like if people are all right. And the aspect that some cameras were not detecting, was like seen in one camera was not seen in the other, so we didn't know if it was like already gone through the passageway or not anymore, or what's happening in etc. in the between. By combining all that with just the logic and the relations I've developed, we can infer and look and see kind of hidden object as well. So we can reason and say, okay, the object is still there even if we don't see in any of these cameras. So that was the idea. So again, adding more intelligence to the level which is required in your project is important, and controlling that when you deploying. So we can see how it was deployed. We have make tests with it was like an international project. Actually, this was with Brazil, by the way, and they have like embedded all that and make tests in the rescue mission, which was combining like a drone, 2 robots on the ground, and 1 UAV. And so it was combining, coordinating, and using all these concepts here. So just now showing you some real world project. Here it was in with Malaysia. So it was in with Factories 4.0. They embedded the ontologies and all these works and concepts just I presented before. Some other human-robot interaction in constrained environment. So it was like for steel factories. This was developed with Italy. They tested in a lab the coordination between drones, grounds, and also like a robot arm putting the right objects, etc. So looking at the actions and all that of robots. So all that was quite successfully tested. So the conclusion is like to design and develop intelligent and autonomous vision systems, it's important to follow a process to see and address the challenges earlier, not at the end. So in order to be sure to get certification, so there's techniques and standards for the algorithms themselves, but also for the data processing, and also for the software aspect, and then the system aspect. We have all the hardware to connect. So all the D7R4 is adapted to smart applications. There's like a lot of project ongoing and following this process, and the choices should be obviously in terms of performance and efficiency. This is always for engineers, it should be efficient. That's not something new, but also the new aspect is about trustworthiness of these new aspects or ethical aspects. It could be safety as well, explainability, but the trustworthiness is at the moment in the heart of the challenges of the community. So once developing your own project, bringing your own piece into that, you need to think about these choices. So here just 2 final projects. So about smart lifts, that's an ongoing project I have. So we need to have like smart lifts, because people don't want to touch on surfaces anymore, like in public spaces. So we brought like and developed an intelligent vision system for lifts, using a lot of the concepts showcased in this keynote, and this was awarded as a paper was like best paper award, and other projects was like with interactions of humans, not only face detection but all these behaviors, ethical behaviors for elderly people. This like the standards we've developed was like the technology award from IEEE received in 2021 for these projects. So all that is these projects, the big projects, were like in partnership. Some more partnerships are across the world. That's another goal of the UN, is like to collaborate internationally. And I would like to thank you very much for listening to me and to having me today with you.
Thank you very much. Do we have any questions from the audience? Okay, I'm going to start with one question. Professor, you talk about performance, but one question I have is also the other metrics related to energy and also cost, which is something that we always think about when we design our systems, low energy and low cost systems. So how are these efforts to include, to provide trustworthiness in systems, and thinking about transparency and thinking about ethics and unbiased systems, how all this effort adds to the cost of the project, and how can we build, continue building systems and also meet this demand? What are you doing about this?
Okay, thank you very much for your question. In terms of costs and energy, so for example, the idea is like, especially when you have to choose and design your algorithms, starting at the algorithm level is not always to jump on the deep learning and expecting 10,000 samples, etc., or like really expensive CPUs. So the project I've shown with the car and the decision tree and the part of the car was specially designed to use low cost devices, requiring low cost equipment, and it was really low on the CPU, but extremely efficient, even much more than deep learning. So again, deep learning is really good in some cases, but the idea is not like to always use one method, not always use one machine learning method or things like that. Each time we're asking question, perhaps there's another one which require less CPU or less costing devices, etc. So in some cases, it's really the right solution to use deep learning, because in terms of efficiency, you cannot have something better than that. But in some of the cases, in some really world cases, you can have like even better accuracy for much lower cost. Also, like using really expensive CPU, or needing to put all CPUs together, or other equipment, like having many servers connected, etc. This is like heating, and so in terms of energy. So again, it's like to re-ask honestly the question each time, not only just using one method, but re-asking perhaps you need another method, etc. So this brings a lot of it opens rooms for research, but actually it's useful to ask the question in terms of engineering, in terms of cost and time. Yeah, so hopefully it answers your question. I think you've got the second questions about how addressing all that takes time. Yeah, so it's why the D7R4 process is flexible. So obviously, if you have a 6-month project, you will not do many iterations, but at least if you go once and you read about the challenges, you need kind of select which are like the most crucial, prioritize the most crucial challenges before moving on the project. So at least having described them, and also like mentioning the book and some of the papers, and still researching on all that is important for the community. We have seen the starters to be at least aware what are the main challenges, and then perhaps depending on the time of your project, obviously focusing on one, which is the most important. But if you are on projects, you are like 3 years project, 2 years project, you have time to address these aspects. So for Smart Leaves, that's a project which was actually it's a 3 years time project. We've got time within project to address this aspect. So Well, yes, it's adding time to think about trustworthiness of this aspect. But if it's done in the right time, I mean, in terms of the process, at the beginning or like rechecking in the middle, that's still efficient in terms of development time. So it's not adding too much. It's rather like if you spend 1 year for a project, don't check anything, and then the project's not a success. Because if you go to the certifier and then it's refused, that means it's 1 year lost. But if you do in an early stage, like after already in the first month, even like after 2 months, you start to have your requirements, perhaps it will add you in terms of development, but not so much because like the entire effort will be then certified and successful. So obviously, this is like how you plan your project, but it's something important if you look at your end goal. So if end goal is to be certified or to sell, or to put on the market any embedded project, etc., product, well, that's important to think about that earlier. So it was like the idea, and it was like based on the many years of developing projects, and also like being involved now many years in the IEEE and ISO standardization effort, trying to combine both. Hopefully, it answers your question.
Yes, thank you very much. We have time for more questions. Yes, please.
First of all, thank you very much for the talk. Very interesting. My question is, in terms of dependable operation of the role environment, when we have intelligent vision systems that is part of this environment and is essential for its operation, how this system guarantees that if it has not recognizing a pattern within a expected deadline, how the whole safety and dependability of the environment is secured if the system fails?
Well, that's a good question. That will be really like project dependent, and what was the specs. Yeah. So actually, yes, how you manage the recovery from a failure, how the failure is important. I mean, in terms of critical, is it a critical failure or not? This is all about how was your specs. Yeah. And then it depends. Well, you need to spot that early if it's like critical failures, etc. Obviously in the first testing, so in the first stage of development in D5 is both development and testing, so you test directly what you've developed. So if you spot that at this stage, well, you hopefully have still time to address. If it's already in the deployment, well, if it's already like in a real world environment, that's worse, obviously. So again, this is why it's sliced in stages, and it's why I advise these reviews as well. So going back and having not only being busy with coding and debugging, but also having this view of what's happening, what's the impact of this problem for the entire project. Yes, so to have this earlier than later, so you can still mitigate the consequences. But obviously, this will depend from one project to another to address that and how to fix that. So, but it's important, yeah. See, exactly, it's important to spot it earlier than later. So it's like iterative, and testing is not just at the end, or like certification. Well, it comes at the end, but here's the idea of the 7R4 is to kind of try to anticipate that by looking and testing, because you can still change your algorithm or other things before it's all embedded, finished, and sent for manufacturing or certification. Yeah.
Okay, thank you. We have time for one more question. Professor Joanna, I would like to ask you about, I have following some heat debate in other countries talking about regulate the industry in terms of artificial intelligence algorithms and how to provide systems that are actually unbiased. Do you think that we can advance in this, and it's really the government the one who is responsible to regulate?
Well, that's a big question. Yes, I agree. That's like the things. Yeah, yes, that's the questions which are debate also like in my areas, etc. Yes. Well, I think like obviously it should be like freedom of research on one sense. So we should not be told which method to choose. But on the other sense, I think there's like care and also concerns from citizens. Like they don't want to see any system. They just want to see the trustworthy systems. So at one point to have standards, well, I think it's a good thing. Now I think the standards are kind of at least in the ones I've participated, I'm not telling you directly which method to choose. So they kind of still, keeping the door open to research. But yes, they say what are the expectations, and our product need to be certified to these expectations. On the other sense, as I'm a lot involved in IEEE, we don't see that as a problem because the electrical devices are already kind of standardized, certified, etc. So why not to do that for AI? Just to bring like you have a safe kettle, you are not take electricity each time you want to boil water, things like that. So it's the same if each time you use your or you talk or with an AI agent, or like you see a robot, or like even like the hoovering robot, etc. You want it's still safe and same kind of trust, bring some kind of trust. So yeah, but there's a lot of debate around. Yeah, so obviously things are ongoing. I've said like half of the efforts are still ongoing. So there's still actually the standardization is also kind of research to have it right, to still open doors to research by ensuring citizen with safe product around them. So
Okay, thank you very much. So let's thank again Professor Joanna for the nice talk. I hope you see you soon here in Brazil. And thank
yes,
you very much.
Very much. Thank you.
A gente vai ter aquele mesmo ônibus que levou vocês para o shopping ontem, na hora do almoço, no